Hello, everyone. All right, so in 6b, this is really going to kind of be a build on to 6a. So we're still doing exponent rules, but we're just going to incorporate one additional rule, and then we're going to incorporate the previous rules. So product rule, power rule, negative exponents, and zero exponents. So for this part right here, this top part is the exact same that we did on 6a. So I'm going to kind of just leave this here. I'm going to kind of skip it. If you want a bigger, or not a bigger, if you want a more detailed explanation on this, I'll just refer you back to 6a, and you can watch the beginning of that video, and you can kind of see what goes into building this table. All right, so looking at the quotient property here. So I'm going to start by expanding this first one, and we're going to discover the rule. So first off, I'm going to have 6x's in my numerator, and then I'm going to have 3x's in the denominator. So just like a fraction, I'm going to start simplifying. So a value over a value, if it's the same, it's going to simplify to 1. So what I mean by that is if I have something like 2 over 2, well, that simplifies to 1. If I have 4 over 4, that simplifies to 1. So I'm looking for what seems like an identity. So here, I'm going to have one pair of x's that simplifies to 1, and I have a second pair of x's that simplify to 1, and I have a third pair of x's that simplify to 1. So what I'm left with are 3 x's in the numerator. So we have x cubed as our final answer. So if you're looking here at your rule, to go from 6 to 3 and to end up with 3, we're going to be subtracting. So x to the 6 minus 3, that's going to be x cubed. So our rule here is going to be subtraction. So we're going to have x to the a minus b. All right, so in addition to quotient rule, we're still going to be bringing back the other rules, and we're going to be incorporating multiple properties into a single problem. So for example, looking at this next problem here, we have n to the third power times n all over n to the fourth. So in the top right here, we can do product property. So because the n's are the same base here, I'm going to do n to the 3 plus 1 all over n to the fourth, which this will end up being n to the fourth over n to the fourth, which simplifies to 1. So, or you could even do the quotient property kind of explanation. So which would be n to the 0, which is equal to 1. So whichever sort of method you choose to solve it is okay. All right, now looking at this next one. So 12a to the 6th over 3a squared. So here, I'm actually going to kind of separate it out a little bit. So you see we have our values, our numbers, and we have our exponents, our variables. So I'm going to kind of separate it out. So I'm going to have 12 over 3, and then do quotient rule with the actual values. So remember, we're dividing here. The actual numbers are being divided, the exponents are being subtracted. So I still want to do 12 divided by 3, which gives you 4. And then when you subtract the exponents, that also gives you 4. So 4a to the 4th is our final answer here. All right, now looking at the next one down here. So remember, we can only combine exponents that have like bases. So for example, I can only combine my m's together. Then here I can only combine the n's together. All right, so because the m's are stacked, that means I have to do quotient rule. So my m in the denominator is going to have a exponent of 1. So I'm going to do m to the 4 minus 1. And then for my n value, I'm going to do 3 minus negative 2. So 4 minus 1 gives you m cubed. And then n to the 3 minus negative 2 is going to be 3 plus 2, which means we're going to have n to the 5th power. All right, next problem here. So this is kind of incorporating a little bit of quotient rule, but also some power rule or power property. So if you notice here, we have c squared over c squared. Those are the same exact values, so those can actually just simplify. Those are just going to 1. So all I'm left with is 1 over b to the 4th to the negative 3rd. So now I'm going to do power property and essentially give everything in the parentheses that negative 3. So when I multiply, I'm going to have 1 to the negative 3, which that's not going to change anything. 1 over 1 to the 3rd power is still 1. Then in the denominator, 4 times negative 3 is going to give you negative 12. But remember, we cannot have a negative exponent, which means we have to flip it. So because it's in the bottom, that means it's going to go to the top. Since we have nothing left in the bottom, that means we write a 1. And then when we simplify, we're simply left with b to the 12th power. All right, next problem. All right, so really similar to the one directly above it, we're going to be simplifying the actual numbers and then subtracting those exponents. All right, so I have 27 over 18, and then I want to do w to the 3 minus 4. All right, so if I simplify 27 over 18, I have a greatest common factor of 9. So that'd be 3 over 2, then w to the negative 1. So because that w has a negative exponent, it's going to go in the denominator with the 2. So I'm going to have 3 over 2w. All right. So that's kind of the gist of quotient rule. So now we're going to start incorporating this and doing more mixed practice. So I will say with quotient rule and all the other properties combined into one single problem, some of these problems can get very challenging very quickly. But we're going to build up to it. All right, so first off, we have x to the 8th over x cubed. So I'm going to do my basic quotient property. So 8 minus 3, which is going to give me x to the 5th power. So that's all for that one. Now looking over at number 2 here, so we have k to the negative 2, h to the 4th over k h to the negative 2. So same idea, I'm still going to do quotient rule or quotient property. So I'm going to compare the k's. So I'm going to have k to the negative 2 minus 1, and h to the 4 minus negative 2. All right, so from here, we're going to have k to the negative 3, and h to the positive 6th power. So because k has a negative exponent, that means it's got to flip and go to the bottom, which means I'm going to have h to the 6th in the numerator, and k to the 3rd power in the denominator. There we go. All right. Come on. There we go. All right. So number 3, anything raised to a 0 power is 1. All right. Number 4. All right, so in the denominator, we have power rule. So I'm going to distribute that exponent. So I'm going to have 9r cubed over 3 squared r squared. Okay, so everything inside the parentheses is going to get the exponent. So now I'm going to start simplifying. So I'm going to have 9r cubed over 9r squared. So what's going to happen here, these 9s are going to simplify, and then I can do quotient rule for the r values. So I'm going to do r cubed minus 2, which gives me r. So our final answer here is r to the 1st power, but you don't have to write the exponent of 1. You can just leave it as r. All right. Now for this next one. So as you can see, these are going to start getting a little bit more complicated. But if you look inside, we have all these A values, and then we also have all these B values. So I'm going to kind of condense the inside before I do power rule. So I would highly recommend starting inside and then working your way out. All right, so I'm gonna have 4/3. Then for my A values, I'm gonna have A to the second power plus 1. And then for my B values, in the top I have an exponent of 3. And because the B squared and B are in the denominator, I'm going to subtract 2 and 1. All right. So next, we have 4/3, A cubed, B to the 0 power, all squared. So if you remember, anything to a 0 power is just 1. So B to the 0 power just simplifies here. So all we're going to have is 4/3, A cubed, all squared. And now I want to simplify this. So now I'm going to have 4 squared, 3 squared, and A cubed times 2. All right, so I'm going to actually move the A value to the numerator. So I'm going to have 4 squared, which is 16, A to the 6th, all over 9. Why is it doing this? There we go. All right. Now looking at number 6. So notice how we have a K on the outside of the parentheses. So right here, this 1/2 on the outside, it's not going to go to the K over here. It's only going to go to the values inside the parentheses. All right, so I'm going to have K m to the 12 times 1/2, n to the 4 times 1/2, and then K to the 8 times 1/2. So from here, I'm going to have K m to the 6th, n to the 2nd, K to the 4th. And then I want to combine the two K values using product rule, which means I'm going to have K to the 1 plus 4, m to the 6th, nope, n squared, which means my final answer here is going to be K to the 5th, m to the 6th, n squared. All right, so moving on, number 7. All right, so if you notice in the numerator, we have power rule happening. So I'm going to simplify all of that first. So I'm going to have 2 cubed, A cubed, B cubed, and then C to the 2 times 3, which gives me 6, all over 6, A squared. Oh my gosh, what's happening? 6A squared, B cubed. Oh my gosh. Cubed, C to the 4th. All right, so 2 to the 3rd power is going to give me 8. A cubed, B cubed, C to the 6th, 6, A squared, B cubed, C to the 4th. All right, so first off, if you notice, your B cubes are the same, so those are just going to simplify to 1. So those are just going to be gone. So now I just want to simplify the rest of it. All right, so I'm going to have 8 over 6 that I need to simplify. Now looking at the A values, I'm going to do 3 minus 2. And the C values, I'm going to do 6 minus 4. So when I simplify 8 over 6, the greatest common factor of 2, it's going to be 4 over 3. Then I'm going to have a c squared. Now, because those are positive, those values are going to stay in the numerator. So I'm going to have 4ac squared all over 3. All right. Number 8. All right, so 36 over 6, that's going to simplify to 6. All right, and then I have my a in the numerator, and then I'm going to do quotient rule for my b values. So I'm going to have b to the negative 2 minus 3. So this is going to be equal to 6ab to the negative 5. And now the b value has a negative exponent, so only the b value has to be flipped, which means you're going to have a fraction. 6a is going to stay on the top. Then b to the 5th is going to move to the bottom and then become positive. All right. So looking at number 9. All right, so if you notice here, we have this negative 1 on the outside, which means we have to do our power rule first. Or what you can do, another option, is you can just move everything to the denominator for that one. So 2ab to the negative 3 over 5a negative 2b to the 4th. So this negative 1 right here is just saying take that entire set of parentheses, take all those values, and just move it to the bottom, is all that's saying. So it's really just going to change the setup. So really, this is the problem that we're solving. All right, so I have 2/5. And then for my a values, I'm going to do quotient rule. So 1 minus negative 2. Then b values, negative 3 minus 4. All right, so this is going to be equal to 2/5 a cubed b to the negative 7. All right, so the a value here is positive, so the a cubed is going to go to the numerator, and then b to the negative 7, because it's negative, it's going to go to the denominator. All right, so in the top, we're going to have 2a cubed, and in the bottom, we're going to have 5b to the 7th. Oh, no. No, 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 no. There we go. Hopefully no one's crying yet. Just me. Everything's fine. All right, number 10. All right, I think the hard problems are actually over with. The rest of these are a little bit more easier. A little bit. All right, so looking here, anything to a 0 power is just 1, so that's gone. And then you just have to move your y to the negative 3rd. So that x squared, because it's a positive exponent, stays in the top. Then y cubed just moves to the bottom and becomes positive. So that's all we're doing on that one. All right. Number 11. So dealing again with 0 exponents. So remember, anything to a 0 exponent simplifies to 1. So that's all you can simplify. So that would just be wxy. The z just goes to 1. So here, I'll actually do this. Parentheses 1, which is wxy. There we go. All right. And last but not least, number 12. All right, so If you notice here, we have two x values inside the parentheses, so I'm actually going to simplify those using quotient rule first. So I'm going to have 5 to the negative 1. Actually, no, let's not do that. 5 to the negative 1, x to the negative 5 minus 3, all to the negative 2, which means here you're going to have 5 to the negative 1, x to the negative 8 to the negative second power. Then here I can do power rule and actually distribute that exponent. So I'm going to have 5, don't need those parentheses, 5 to the negative 1 times negative 2, then x to the negative 8 times negative 2. So I'm going to have 5 to the positive second power, then x to a 16th power, which means I'm going to simplify this one more step. So 5 squared gives you 25. So you're going to have 25x to the 16th power.